This is Julie with smartQED, and we are going to start with today's webinar, Efficient and Scalable Root Cause Analysis with Smart Fishbones. So I will let Ron do the introductions. Ron.
Yes, indeed. Thank you. Good morning, everyone, and a very warm welcome to our webinar. I would like to thank you for taking out your time from your busy schedule to attend this event, and we feel very highly privileged to have all of you with us today. I'm Ron Spencer from smartQED, and I have the honor of introducing the speakers today. So please welcome Julie Basu and Terry Gallagher, the founders of smartQED. Like all of you, both of them have a lot of experience in problem investigations and root cause analysis, and they'll share their insights with us today. And we also have with us Mr. Sangeet Pal, who is our AI and ML champion and a data scientist. With this, I would request Julie to take over and start the presentation. Please take over.
Yes. Hello again. We will start with the topic, Efficient and Scalable Root Cause Analysis with Smart Fishbones. This is a topic very near and dear to our hearts, especially for Terry and me. We have been involved in problem investigations and RCA for many years. So what is root cause analysis? I am sure most of you here are familiar with it. And thank you, for your interest in this webinar. So just to recap, root cause analysis involves finding the true root causes of problems. So you typically would do an investigation to identify what were the contributing factors for the problem. Now, not every investigation is a root cause analysis. There are specific features of RCA. For example, it has to be methodical. You have to explore all probable causes. Now, all is a very comprehensive term, and it is indeed meant to be a comprehensive exercise, in-depth analysis of all the aspects of all probable causes. So this can get pretty intense. And RCA is also fundamentally collaborative, because typically one person does not understand an entire system, especially if it's a complex one, and you will need to involve subject matter experts in their individual domains. They would have the knowledge to come together and collaborate to do a proper root cause analysis. So root cause analysis, of course, will require a lot of your time and effort. So the question is it worth it? And we believe the answer is absolutely worth it. The benefits may be a bit longer term, but they are absolutely worth in terms of time and effort. So why is it useful? It will help you prevent repeat incidents, comply with regulations. In some cases, it's not even a choice. For example, if you have a traffic accident or a helicopter crash, an airline crash, it is required by the government to do the RCA. And the intent is to, of course, learn from the event and increase the reliability of your products and services. So this might take a bit of time to see it, but the longer term benefits are definitely there, very significant, and you cannot substitute RCA with short time patches or just shortcuts or workarounds. So this this technique of RCA is used in many domains, including finance, healthcare, IT, manufacturing, aerospace, automotive, transportation, and many others. And from the large number of attendees of this webinar, we believe there are actually people from several domains. So you must be already familiar with this, but just to set the context, there are many popular methods, actually several popular methods, I should say, for RCA. Number one is 5 whys. You basically ask why did the problem happen, and then you dig down to understand the deeper level causes. Another very popular method is the Fishbone or Ishikawa diagram, which is a visual technique. You take the problem, break it down into its causes and subcauses, and I'm sure many of you are familiar with this technique. There are tabular and other methods like Kepler-Trego and Taproot, Apollo that are also used. So we would like to stop here and get an idea of what kind of tools you use or what methods. So please feel free to share on chat. I believe I've enabled chat sharing, and Ron will be monitoring our chat. We would love to get your feedback. Also, if you want to email us online, you can do that. Later, info@smartqed.ai. You can connect with our on LinkedIn with our company page. Okay, I do see a chat message. So Ron, you may be able to. So examples of RCA Fishbone. I've just given a couple of examples, one from healthcare. Wrong medication, let's say, was prescribed to us, not prescribed, administered to a patient. It could have been the physician's issue, wrong diagnosis, maybe your incorrect medication, or it could be a nurse's problem. The patient's problem, patient could have taken a wrong medicine. It happens quite often. And there may be other issues like the medicine that was delivered was wrong. Also, there are, ransomware attacks, many kind of issues in IT, security, cyber security. So we have several RCA templates on our community website. You can find these templates at community.smartqed.ai. Ron is going to share the link on chat, and you can.
Yes.
Yes, Ron.
I will. Before that, I would just like to point you out that George is saying 5 whys, breakdown to people, process, technology, and breakdown.
Yes.
Gulshan is saying why. Rajkumar is saying pain impact analysis.
Okay, great, wonderful. So, but I'm assuming all of you have seen this diagram, kind of fishbone diagram, because today's webinar focuses on the smart fishbones. So let's see. We would like to actually walk through a real complex RCA. Now you can interpret this to mean it's a really complex RCA, which is true, and it's also real life. So both interpretations are true. And that is going to come from the NASA report on the Toyota unintended acceleration investigation. Ron is again going to post this link. It's publicly available information.
Yes, I've posted.
Okay, yep. Great. Let me just quickly show you, not to dig deep, but there was in a few years ago, 2011, 2012, an incident with the Toyota cars where they were having unintended acceleration, which is of course a very scary thing. So the National Highway Traffic Safety Administration started an investigation, and the NASA team was pulled in, and they have of course used fishbone diagrams to do their detailed analysis. So here is the report. If you see, they have actually done fishbone analysis for all the full fishbone diagram, and then each of the individual components: throttle, pedal, cruise control, idle speed, etc. All in all, like 9 or 10 of these. Now, if you look at the main fishbone, it's kind of crazy. It's a little scary because it was a very in-depth investigation with about 170 something, close to 170 causes. Yeah. So as you can see, fishbone diagrams are very useful for visual analysis. However, it does get very complex if you are, it can get very complex. Yeah. And if you're drawing it, especially on a board, it is really difficult to keep track. So here are the individual diagrams, and you can peruse this at your leisure. Then the NASA team actually had analysis on each of these components. They did their analysis and investigations, description and disposition, detection and system level mitigations, and they have numbered these causes, as you can see, 2.1.1.1.1, and basically analyzed each and every cause at each and every level to the best of their ability, I'm sure. Yeah. And then likewise, the same thing was done for the pedal function fishbone. Multiple teams were involved, obviously, right? Now, getting back to our presentation, real live RCA can get pretty complicated, and the NASA team did, of course, a great job, but I'm pretty sure you guys also handle complex issues. So we were just curious to understand how complex are your problems. You can say more complex than NASA, very complex, moderately complex, not complex at all. This information is important to us. We just want to understand where you're coming from so we can better design, our solutions. Please share on chat. Okay, so moving on, challenges of RCA, right? We already mentioned RCA takes a lot of time and effort. So there are two main challenges of, their efficiency and scalability. So when you're analyzing a problem, you have to make optimal use of time and resources. Sometimes the analysis can go on for a few hours. Sometimes it's a matter of days, sometimes weeks and months. Yeah. So it is important to keep this aspect in mind. We wish we had all the time to do RCA, but it's not possible generally because you have other work going on as well. And scalability comes in as well because you have to handle very complex problems, and we saw it can get out of hand pretty quick because the sheer number of aspects and causes and subcauses, subcauses are can get pretty large. And of course, you can be dealing with large teams, and teams are often working in a distributed environment. So the difficulties that we have faced include unclear strategy. Strategy can be unclear for a number of reasons. I have just listed one. For example, let's say we have a new technology and we don't understand, when a problem happens, what are the aspects that we need to look at. This happens these days quite often because technology is rapidly evolving, and oftentimes, you don't have the adequate number of experts with adequate knowledge, so causes could get overlooked. Yeah, so your RCA could be incomplete even though you have given it a best shot. This does happen. Complex problems, many probable causes, large virtual teams. So here the difficulty is a little bit different. So many people could be involved and they could be saying different things, doing different things. There is typically an RCA coordinator who facilitates the analysis, especially for large problems. And these coordinators have a huge issue on their hands, who's doing what, and to pull it together into a report, that itself is a huge exercise. So our solution is we wanted to address these two issues. Can we improve the efficiency and can we improve the scalability challenges in doing an RCA? Right? So for RCA, it has to be methodical, comprehensive, collaborative. We already said that. But it also ideally should be self-learning. So this is the age of AI. It's the digital era. We are undergoing digital transformation, and we want our machines to not be dumb anymore, but to learn as we are working in those tools and essentially help us solve problems instead of just being a recording tool like Excel or some sheets, or even a drawing tool. So we are not a drawing tool. We are an active system that actually self-learns with AI and ML algorithms. So let's see how it works, right? So smart Fishbones obviously go beyond the basic capabilities. So we can associate details for each cause in context. And we will shortly see a demo. Views are automatically layered. This part is important because we saw how easy it is to get lost for in-depth analysis. We have integrated fault status. You can indicate with colors how you found, what is the outcome of one cause. And we also have a templating capability, which is very powerful. You can mix and match templates depending on the components. Like throttle could have its templates and pedal could have its template. And depending on what you're analyzing, you can put in the proper templates. And of course, last but not the least, the recommendations are generated by our ML algorithms. So imagine the fishbone diagram that has an ML brain attached to it. So it's watching what we are doing and trying to say, oh, they cleared this cause, oh, they found this symptom, and it creates the associations to help us in future. So let's see a quick demo. The NASA Toyota RCA fishbone recreated as a smart fishbone in our tool. The problem of unintended acceleration can be broken down into many causes and subcauses, and each cause can have its own notes, evidence, and actions associated to it. This makes it very easy and efficient to keep track of all the information in the right context. You can view the details by clicking on these small icons to see what was entered by whom and when. You can also see all the details associated to a cause all at once by clicking on the cause details section at the bottom. The problems will typically manifest as errors and anomalies in the system. These symptoms can be gathered up in this right panel called QED clues, and they can be associated with any component in your system. You can create details for each clue, and using this pin icon you can also associate it with any cause in the fishbone. For example, here we have environmental effects on electronics with thermal as a subcause, and if we observe some faulty thermal effects in the system, we can create a clue and pin it to this cause. If we change our minds, we can always unpin it. This association allows our ML algorithms to learn from our observations and to make probable cause recommendations for future problems. This root cause analysis was quite in depth, and it has 6 levels of causes and subcauses that were investigated. Now in our smart fishbones, we only show 2 levels at a time so that we don't get lost in the complexity. Further details are shown as nested fishbones, which are indicated with folder icons and automatically created as you add more levels. You can easily drill down to see further details by clicking on these folder icons and see the next layer and the next if you have created it. Now this is the bottommost layer of this investigation. To go up, you can click on the up arrow shown on the folder icon on the head, and also you could click on the links that are shown here. If you wish to see the entire set of causes that were investigated, you can click on the cause tree panel here, and this shows the full cause hierarchy. For this problem, NASA team actually looked at 170 causes, and the entire hierarchy can be seen here. Now let's assume that shaft jammed is found to be a contributing factor for our problem. Now we can set the status of this cause to be a contributing cause, and the system asks us to add a clue as evidence. In this case, I've already attached it, so I'm going to skip it. And once we have updated it, the color of this cause changes to red, and it propagates all the way to the top, clearly indicating which causes were contributing factors. This makes it very easy to know the results of the RCA. And this information is also used by our ML engine to make recommendations for probable causes. So that was a very quick overview of our smart fishbones. You can learn more. You can watch our earlier webinar. Here is the link. Ron is going to post it on chat. You can also go to YouTube and search for smartQED. You can book a detailed one-on-one demo with us. There are many aspects to the fishbone that we didn't cover here, like reporting and others. So let's move on. Now, insights are basically, generated by the ML engine that takes symptoms that you enter and generates probable cause recommendations. Let's see a quick demo on that.
Right, so we just saw how to use the investigation maps to solve a problem. Now, turns out, do we have to go through that whole process every time we come across a problem, especially if it's a problem that has happened earlier, so-called a repeating problem? Turns out no. And that's where QED Insights comes in. All that we really have to do is to enter the clue or the symptom of the problem at hand, something like unable to enter purchase order. And thereafter, all we need to do is click this button here, and at this click of this button, QED Insights, which is our ML powered algorithm, is going to sift through our database, fish out all the problems of a similar nature that have been solved in the past, and it shows that list out here, and we can compare and we can check out what was similar, what the matching clues or symptoms. Even the unmatched symptoms are here if you wish, and take a look. If in this case, of course, there was no unmatched symptoms, so that's that. But and if you like, and if you think that a particular problem is useful, you can use this flag to accept it, or you could reject it, or you could check further, whatever you wish to do. But that still leaves us the task of going through all of these problems and figuring out what caused the problem and how it got solved, etc. Well, it turns out that the ML powered algorithm has gone a step further, and it has done that for us already. And the results are displayed in summary here, most likely causes and recommended actions. So if you click here, you get to see that there were 7 problems that matched. 4 of them had a problem with the database, 3 of them had a problem with the user. There was an upgrade issue with the database or a permissions issue with the user, etc. If you wish to know details about the individual problems, you can click here and you will get there for further details. Likewise, as to what needs to be done to solve these problems, these are our recommended actions. Once again, you could take a look at the details. So if it was a database issue, we need to change the configuration. If it was a user issue, maybe some documentation needs to be updated. Again, if you wish to know the details, you can click here. And finally, another thing that our ML algorithm does for us is that it creates what is called as an aggregated fishbone, which is nothing but, let me enlarge this a bit, which is nothing but a visual summary of the probabilistic distribution of all the underlying causes that have gone to create this problem.
Okay, so that was a very quick overview of the ML part, the insights and recommendations, and you can always accept the aggregated fishbone to jumpstart your investigation.
Right.
So let's move on. The benefits should hopefully be clear by now. Our goals were to make it more efficient and more scalable. So we make it more efficient by enabling clear organization and easy status tracking, especially when you're in large teams. It really helps to see the color-coded status, so you don't have to go reading each cause and what was its disposition and description. They're all available in context. It scales easily to complex problems and large teams. The Smart Fishbone is, of course, collaborative. You can have multiple people updated at the same time. And last but not the least, it is also acts as a virtual subject matter expert, because it's always trying to learn from human work. It understands the colors, and it understands the symptoms and the association of symptom to causes. So it is actually able to suggest the causes like we saw. So Smart Fishbones would hopefully make your work faster, easier, and smarter. So we would love to get your feedback on what you think. If you could benefit, your RCA process could benefit from the Smart Fishbones, please share your comments on chat, and Ron will be summarizing them later. Thumbs up, thumbs down. Any feedback is appreciated. Your thoughts, please. Okay, so let's move on. The next steps, what you could do after this, you can open a free account on our application, app.smartqed.ai. We have a special offer going on for the participants of this webinar. We would give a free 2 hours hands-on workshop if you or any of your team members are interested. You can follow us on LinkedIn. We have a company page with hundreds of followers. Check out our free templates at community.smartqed.ai and contribute to our community template library. So we allow domain experts to share their knowledge through this community templates, and we have an ambitious goal to build up the template library. It's free for anybody to use on the free accounts as well as on priced accounts, and they also get published after review on our community site. So with that, I will stop and wait for some questions to come in. Ron, would you like to just
I
kind
would
of
just
wrap
like
up?
to interject and say that we are getting a lot of thumbs ups, lots of thumbs up, and I would like to ask all the people, all of them, if they have any questions,
Yeah,
please go
Ron.
ahead and shoot.
Yeah, I'm sorry, Ron, your voice is cutting off a little bit, but please feel free to contact Ron or me. We are on LinkedIn as well as on our company page. So any questions? Terry, do you have any comments? Would you like to say something to the participants?
Well, basically, I think you've seen the demonstration here. You can sort of see how the tool works, how it's more than a drawing tool. It's also, it's handy for doing more involved root cause investigation, as well as trying to resolve problems quickly. Once you get some database in your case database, you can basically just feed it symptoms, and it can tell you on basically a problem signature, similar to a virus signature, what it sees out there, what are the likely causes of your problem, and recommend some solutions. So it's also handy for that.
Right. And Terry, you and I, we built this tool from our own experience. Would you just say a few words about what kind of RCA you were doing in your work?
Well, I was a crisis manager, and also involved in many like P1 high impact incidents and so forth, public facing, some of them, most of them internal. Obviously there's lots of challenges trying to move quickly, trying to understand what the root cause is and what solutions to apply to restore service as quickly as possible. Oftentimes things get overlooked and missed, and after service is restored, it's hard to sort of get everybody's attention and go back and gather the artifacts and useful information to do some sort of post-mortem or related type of reporting there. So this tool also tracks a lot of that stuff. It's very handy for just keeping track of that type of information, the timeline, who did what worked, what didn't, etc.
Yes, absolutely. So Ron, are there any questions for Terry or me?
No.
Right now, okay.
Questions.
That's great. So looks like, we have convinced everybody on the call. We would love to have you open accounts and try out the tool. I know everybody has their own favorite methods, but this tool actually is special. Terry, like he mentioned, said we wanted to build something that we could use ourselves, and it is actually built from our own experience and insights that we ourselves got in the course of our work. So it's not a tool that kind of a brainwave from one day, but it's really built based on our collective insights. And we have done a whole bunch of client interviews, if you will, or community, trying to gather community experience, what works, what doesn't work, how we can improve. So we would love to hear your thoughts. And I will let Ron finish up this webinar, unless Terry, you have something more. Go ahead.
I actually have a note from George. Is it possible to unmute George once?
George, are you able to unmute yourself? Otherwise, Sangeet, maybe you can unmute George.
Yeah, I'm here.
Okay. Yes.
Yes, George, please go ahead.
Yeah, I'm just pointing out the fact that it's great to see a tool that's actually tracking occurrences. I've always known in the industry for problem management, it's one of the key things that get overlooked on a year-to-year basis or on a bi-monthly basis. Just I enjoy that feature, at least from the training here.
Perfect. Thank you so much. It's really,
Yes, actually, I'd like to add to that, Julie.
Please.
That's a good point. So obviously at many organizations, you see either similar or sometimes the exact same problem occur over and over again. And it's very frustrating to those who are involved and impacted by that. This tool does help you track the individual occurrences of a particular problem and perhaps what differing flavors there might be in terms of whatever the root causes are, the actions taken, and so forth. And it does have the probabilistic analysis capability to sort of understand how many different flavors of a similar problem you've had and summarize what are the top hotspots of that problem. So ultimately, you'd like to see that was getting some attention and ultimately the root cause addressed so that you no longer continue to see it. And this tool can help quite a bit with that.
Right. And with problem management, I mean, that's the number one goal there, is to either reduce impact or seek a way for permanent actions. So that's a good feature. One thing I didn't notice, and I don't know if I just missed it, does the smart QED, does this also track like a risk of reoccurrence level, from critical to like low standards?
Very good question. Very, very good question. Terry or Julie, who would like to take this?
Yes, so I will just give a quick overview. If you want to, have details, we can always have a follow-on conversation. So we do have all the data, right? So we see that, a root cause, like let's say the car failed, the throttle failed, in another case, the pedal failed in this case, and the system is able to gather up all this data. And yes, we have a dashboard where you can see which cause was the most frequent, and that will give you an idea of the recurrence, the likelihood of recurrence. So let's say the pedal fails most frequently, right? So that analysis happens across all problems, and we actually do have a great dashboard designed by Terry here himself, and you can view those analytics across a certain time period, that from January to December 2021, what is my most frequent cause, or what was the failure point, so that you can plan for the future and what's the likelihood of recurrence.
Right.
Yes, I'm sorry we don't have a dashboard demo right here, but Terry put in a lot of work into the dashboard. We would love to show you a one-on-one demo. Please feel free to reach out to us. We are kind of a little bit over time, so I would like to thank everybody, and also Terry, because Terry is, has some family emergencies going on. He's made a special effort to be here today. Thank you so much, Terry.
You're welcome.
And also the participants, George and others that spoke. And please do reach out to us. We are here to understand your requirements and the pain points you face, the challenges you face. And we would love to work together, collaborate, and of course, build up our community. So please follow our LinkedIn page if you are not already doing that. And we post regular updates there. Okay, so with that, I will stop. Ron, do you want to just say a few words, or?
We are a bit over time, so I would like to say thanks to everyone for taking out their time and joining this webinar. And I'm literally thankful to see so many thumbs up over here. And George and other participants, I can tell you names, we have Anusha, we have George, we have Parag, we have Karan, who all are actually enjoying, David, who have enjoyed this session actually, and I'm sure we would be basically meeting them, one-on-one, definitely.
Perfect. Thank you so much.
Yeah.
Okay, with that, I will say bye and end this conversation. Please stay in touch, and we hope to learn and do more together. Thank you.